what's up? It's Ryan. Today we're going to be talking about hyperbolas. And you may, if you go back to the lecture about circles, we talked about this double napped right cone. And hyperbolas occur when we slice that double napped right cone vertically. That's going to create two curves. Sometimes they're going to be horizontal, like this, and sometimes they're going to be vertical, like this. And one interesting thing about hyperbolas, one cool thing, is going to be we have these two foci here. And they're sort of inside this curve, right? They're inside that curve. And if we pick any point on the hyperbola, say for example this point up here, and we take the distance from one of the foci to that point and the other distance from the other foci to that point, and we subtract the two, we find the difference between those two distances. It's always going to be the same value. So d1 minus d2 is going to remain constant. And that's one interesting fact about hyperbolas. Okay, so let's talk about some types of hyperbolas. We have horizontal hyperbolas that extend horizontally in this direction, right? And vertical that extend up and down, right? And so one way we can find the center of this hyperbola, it's going to be when we know the foci, and right, these two are the foci, and this one is going to be these two. The center is just going to be the midpoint of those two foci, midpoint. And so in this case, the center is going to be this value right there, this value right there, and that's the center. The asymptotes. So the asymptotes, we'll get into this a little bit more later, but when we're graphing, we're going to create this rectangle. And essentially what we're going to do is we're going to create diagonals that go through the corners of those rectangles. And essentially what we're going to do is we're going to graph this in such a way where this curve approaches those diagonals but never actually touches it. So it's almost like it's a limit. It's going to keep on getting closer and closer and closer, but it's not actually going to touch it. And that's the definition of an asymptote. And so these diagonal lines are going to be our asymptotes. Our vertices are going to be the points on the actual graph. So, for example here, this is our vertice, this is our vertice, and here, this is another one of our vertices. And they're going to be plus or minus a unit away from the center. And we're going to talk about that a little bit more later as we get into the actual standard form of hyperbolas. But yeah, our co-vertices are going to be on the other edge of that box we create, that invisible box we create. And that's going to be this point, and this, in our vertical hyperbola, it's going to be these 2 points. They're going to be plus or minus b units away. And this is sort of similar to ellipses, but we do have a different equation, a slightly different equation. The foci are going to be plus or minus c units away. The formula to find c is similar to what we talked about with ellipses, but it's actually just the Pythagorean theorem. It's going to be, my bad. It's going to be c squared equals a squared plus b squared. And we'll use that a little bit more later in this lecture. Sorry, I had to change locations. Okay, so For the standard form of a hyperbola, it's going to look very similar to that of an ellipse, but we're going to have one difference, and that's a subtraction sign. So when we're drawing this, our standard form equation is going to be x minus h squared over a squared. But now instead of a plus, we're going to have a minus y minus k squared over b squared equals 1. And so this is going to be our standard form for a horizontal hyperbola. And so that means we're opening up horizontally, something that looks like this. And so basically one thing to remember, if we have our x term first, that means it's going to be a horizontal hyperbola. If we have our y term first, it's going to be a vertical. And another thing to remember is that this a is always going to be under our first. It's always going to be under our first term. So that's just a couple of points. This is pretty expected for our vertical parabola, y minus k squared over a squared minus x minus h squared over b squared equals 1. So we see that all these are equal to 1. We see that our a value is under our first term, our b value is under our second term, and whatever term it starts off with, if it's y, it's vertical, if it's x, it's horizontal. Now for the equations for asymptotes, for the horizontal hyperbola, it's just going to be y equals plus or minus. We have to include that plus or minus, right, because it's going in both of these directions. Plus or minus b, sorry, this b over a times x minus h plus k. And here for our vertical parabola, we're just going to take the reciprocal of that slope. So we're going to say y equals plus or minus a over b times x minus h plus k. And generally, most of the time when we're trying to find these asymptotes, it's generally just going to be for graphing purposes. And so in my experience, I don't really use these equations that much. I just try to create this box. Right. Okay. So let's get on to graphing hyperbolas. So we have x squared over 4 minus y squared over 9 equals 1. So we don't have anything inside, like up here, for example. We have x minus h and y minus k. In this case, we're not subtracting anything from either x or y. The only thing we're subtracting is 0. So our center is just going to be 0, 0. And right, our vertices, actually, let's graph this center right here. Our vertices are going to be, if we scroll up, are going to be plus or minus a units away. So one thing we want to look at is we have our x term first in this example. So we know it's a horizontal hyperbola, so it's going to look something like this, right? And so what's our a value? Well, our first term is, the denominator of our first term is always going to be equal to a squared. So a squared equals 4. So that means a equals 2. So I'm going to move 2 units left and right in the horizontal direction because x is our first. X is our first term, my bad. And then here, I'm going to create co-vertices. So here, b squared equals 9. And so that means b equals 3. So I'm going to move up and down 3 units. And that's also another good point to talk about. Sometimes our b value will be greater than our a value. It does not really matter. These two, they don't really, it's not important how big they are, or like which one comes first. Okay. So from here, I'm going to create a small little box. Okay, so here I'm going to create lines. I'm going to create a little box in the center. And then I'm going to create lines, diagonals. So here it's going to be a slope of 2/3. Sorry, 3/2, my bad. Something that looks like this. It's easier with a straight edge. Something that looks like that. And also in this direction. Sorry about that. Okay. Something that looks like that. And now what we're going to do is, right, these are our vertices. So now we're just going to draw this in. Oh, that's horrible. We're going to draw this in so that it approaches our asymptotes, but it doesn't actually touch them. So something that looks like that. Great. And so our vertices, if we just look at our graph, it's going to be 2, 0, and then -2, 0. Our co-vertices are going to be 0, 3, and 0, -3. And then our foci, we're going to have to use this equation. So this is just the Pythagorean theorem, or it's the same thing as the Pythagorean theorem. C² equals A² plus B². We have A is equal to 2, so 2² is 4. B is equal to 3, 3² is 9. So that means C² is actually equal to 13. So C is equal to √13. And our foci are going to be, if we look up here, they're going to be inside the curves. So up here, right, our foci are going to be plus or minus C units away. And so that means they're going to be sort of nudged inside this curve. Let's see. So I'm going to, √13 is going to be about a little bit less than 4. So we're going, but greater than 3. So I'm just going to put a point, maybe like right here. And a point right here. And that's our foci. And so our foci are going to be going in the x direction. So we're going to have √13, 0, and then negative √13, 0. Our asymptotes, so our asymptotes in this, right, it's a horizontal parabola, so we're going to have b over a as our slope. So we're going to have y equals, well, our b value is 3, our a value is 2, so we have 3 over 2 times x minus, and we said h and k were both 0, so times x plus 0, sorry. So we're just going to have 3 halves x. And for our other asymptote, it's just going to be minus. So negative 3 over 2 or negative 3 halves x. Okay. Question 2 should be relatively simple. Use these same exact techniques. Let's do question 3 together. So what's our center? Just looking at this, we have x minus 3. So that means our h value is going to be 3. And then we have y minus 2. So our k value is going to be 2. That's our center. Let's just plot that. 3, 2, right there. And then our vertices, we're going to want to look at our a and b values. So this is going to be another horizontal parabola since we have our x value first, or our x term first. And so it's going to look something like that. And so our a value is always under our first term. So a squared equals 25. That means a equals 5. And so since this is a horizontal parabola, we're going to be going left and right 5 units. So if we go left 5 units, we end up at the point negative 2, 2. If we go right 5 units, we're going to end up at the point 8, 2. And now for our co-vertices, our b squared value is equal to 16. So that means b equals 4. And then that means we're going to be going up and down 4 units. So this is our co-vertice. We're going to be going up 4, and that gives us 3, 6, and down 4, which gives us 3, negative 2. So now here I'm going to create our little box so that we can create our asymptotes. This might be helpful to zoom in. Something that looks like that. And then we're just going to go through this. So you see, we go down 4 and across 5. So we're just going to try to eyeball it. Down 4, across 5. I think that point should work. Okay. And then in the opposite direction, this way, across 5, and then up 4. So about there. And here, this is a horizontal parabola as we drew over here. So these are our vertices, so we're just going to create a hyperbola that approaches these asymptotes but never actually touches them. Something that looks like that. That was bad, but hopefully you get the idea. Okay, so now we have to solve for our foci, which means we have to solve for c. And right, c squared equals a squared plus b squared. So c squared is going to equal a squared. A is equal to 5. A squared is 25 plus b squared. B squared is equal to 16. And that's going to give us a value of about 41. Right? Not about. It is going to give us a value of 41. And so that means our c is going to equal root 41. Right. And now we're just going to be moving. We cannot simplify root 41. So we're going to be moving in the horizontal direction from our center about root 41 units. And root 41 should be right in between 6 and 7. So we're going to count 6 units, or at least try to plot where it might be. So this is 6 units, probably over there. It's probably going to be near there. And so our foci is just going to be 3 plus root 41, since we're going the x direction, 2. And then 3 minus root 41, 2. And our asymptotes before, this is a horizontal parabola. So we have b over a. And that means we do y equals, b is equal to 4. And a is equal to 5. So we're going to have 4/5. That doesn't look good. 4/5. X minus h, which is 3. So x minus 3 plus 2, which is our k value. And then we're just going to make it negative 2. So negative 4/5. X minus 3 plus 2. Okay. And I'd say try number 4 on your own. And yeah, it's just going to be using the exact same concepts we did here, except both of these, be mindful of which term comes first. And that's going to create some graphs that look a little bit different. Okay, in this case, we're not given our equation in standard form, so we have to do it ourselves. Remember that equations for hyperbolas, they always equal 1. So we need to divide everything by 100 so that it equals 1. And this is going to create y squared over 25 minus x squared over 4. And it's all going to be equal to 1. And so what's our center? Just looking at this, it's just going to be 0, 0. We don't have any horizontal or vertical shifts. So I'm going to plot that right here. And then our vertices, well, our y term comes first in this case. So we're going to be graphing something that looks like this. And so that means our a value is always going to be on our denominator of our first term. So a squared equals 25. That means a equals 5. And so that means we're going to count up 5 from our center. And we're going to get that point right there, which is going to be 0, 5. Then we're going to count down 5. We're going to get that point, 0, negative 5. And those are going to be our vertices. Our b squared value is equal to 4. So that means b is equal to 2. So So we're going to count horizontally, go in the x direction, 2. And so that means we're going to create 2, 0, sorry, which is there, and negative 2, 0, which is there. So now is a point where we draw our little box. A little rectangle. And then what we want to do here is we just want to connect the diagonals. So we're going to have, or make our asymptotes. This is down 5 over 2. Sorry, I'm really bad at counting these things when they're so small. Yeah, right there. Something that looks like that. And from here, right, now we can start graphing our actual hyperbola. These are our vertices, so that means our hyperbola goes through those points. We're going to create something like that. Perfect. And our foci, we use c squared equals a squared plus b squared. C squared equals 25 plus 4, which equals 29. So C equals root 29, which we cannot simplify. And so, sorry, my bad. And so our foci are going to be plus or minus c units away in the y direction, right? They're going to be inside. And so that's going to be about like in between 5 and 6. So if we just try to graph this, it's going to be right here. This is where our foci are going to be. Okay. So we're going to have 0, comma, root 29. And right, we're adding this on to our center and subtracting it from our center in the y direction, right? And so our asymptotes for this one, it's a vertical hyperbola. And so that means we have a over b. So our a value is 5, and then our b value is 2. So we're going to have 5 halves x minus 0. Sorry, just going to have x minus 0, which is just x, and then plus 0. So I'm just going to leave it like that, and then we're going to do the negative version of that. Easy. Okay, so here I'm actually going to do number 7. And for actually all 3 of these, we're going to need to complete the square. We're going to need to transform this a little bit. And so, sorry, let me zoom in. Let me first write this out separately. We have negative 36 x squared, and then we don't have any other x term. So I'm just going to leave it like that. And now we're going to have plus y squared minus 6y plus, I'm going to leave space, and then that's going to be equal to negative 45. And what I want to do is same thing we did with circles and same thing we did with ellipses. We are going to want to make this into a perfect square. And so I'd recommend, if you're having a little bit of trouble on that, go back to the circle video. But essentially what we want to do is we want to have x plus b over 2 squared. So that means when we FOIL this out, our c value is going to be equal to b over 2 squared. And so our b value is 6. So 6 over 2 is 3. Sorry, b value is negative 6. Negative 6 over 2 is negative 3. Negative 3 squared is 9. So we're going to add 9. But we need to add 9 to both sides. And that's going to allow us to write negative 36x squared plus y minus 3, right? Because we are doing plus b over 2, and b over 2 is equal to negative 3. So y minus 3 squared equals 45, or negative 45 plus 9, which should give us negative 36. And at this point, we want our equation for hyperbolas to be equal to 1. So I'm going to divide each term by negative 36. And that's going to give us x squared, x squared minus y minus 3 squared over 36 equals 1. And from here, we can graph this with some ease. So we're not horizontally shifting our x value, or this hyperbola, as evidenced by no sort of plus 2 or anything like that. So our center for our x value is just going to be 0. Here we have y minus 3. Since it's opposite, it's plus 3. So our center is 0, 3. We graph that right there. And here are vertices, right? Let's just take a second to check this. Our x value is coming first, meaning it's going to be a horizontal parabola, so it's going to look like that. And so if we solve for our a, this is essentially saying x squared over 1. So that means a squared equals 1. So that means a is equal to 1. So we're going to count 1 unit in the x direction in both left and right. Something like that. And those are going to be our vertices with the coordinates 1, 3 and negative 1, 3. Our covertices, well, our b squared is equal to 36. So that means b equals 6. So we're going to count 6 units up and down. This is going to give us this point right there, which is 0, 9. And this unit here, which is 0, negative 3. And at this point, I'm going to create a rectangle that looks like this. And then we're going to create our diagonals, which we went up 6, so we're going to have a slope of 6. Sorry, this is just a lot of, oops, that's horrible. This is just going to be a lot of drawing. And trust me, I'm a better hardest than it shows right now. Something or this horrible. Or, yeah, doesn't matter. You get the idea. And you probably should be a little bit more exact on your tests and quizzes. Probably use a straight edge. But here, these are our vertices. So we're going to go through these points and we're going to approach our asymptotes but never actually touch them. So it's going to look something like this. Ooh, that's bad. That was bad too. But they're really stretched. They're super wide. Our foci, we're going to use c squared equals a squared plus b squared. C squared equals 1 plus 36. So C is going to equal root 37, right? So it's just going to be a little bit more than 6. And that means so we're going to go in the x direction. And 1, 2, 3, foci is going to be right there. And then also 3 right there. And so we're going to have root 37, 3, and then negative root 37, 3. And so our asymptotes, this is a horizontal parabola. So we're going to have b over a. So y equals 6 over 1, which is just 6. And then x minus k, but in this case, x minus h. H is equal to 0, so x minus 0, we don't need to put that. And then plus k, which is 3. So we're also going to have the negative version of that, and something like that. Boom. And this should be very similar, except now for number 8, you're going to actually have to do completing the square for both x and y. Okay, so here we're just going to rewrite our equation for horizontal and vertical hyperbolas, right? It's just x minus h squared over a squared minus y minus k squared over b squared equals 1. And this we're just going to switch x and y. And so if we remember, HK is going to be the center. And then A is actually going to be the distance from the center to the vertices. And then B is the distance from the center to the co-vertices. Okay. So now we're going to be given a graph, and now we actually have to create the equation from that because we want to go in both directions. Here, first order of business would be what's our center. It's pretty apparent. It's just going to be 0, 0. So that means we don't have to horizontally or vertically shift it, have anything inside these parentheses. And also here, is this a vertical or horizontal parabola? It's a vertical, so our y term is going to come first. So I'm just going to write y squared over something minus x squared over something. That's what we know right now. We know that the y term comes first because it's vertical, and we know that we're not horizontally shifting, so we don't need anything sort of inside these parentheses. And we also know it's equal to 1 because it's the standard form for our hyperbola. So now we need to determine our a and b values. Well, from our center to our vertice, right? This is our vertice. That's going to be 1 unit. And so that's our a value. So a equals 1. So that means under our first term, a squared, it's going to be 1 squared. So it's just 1. I'm just going to put 1. But you could just put y squared. And here, if we count in this direction to our co-vertice, which would be right here, that would be 4 units. So our b value is 4, so b squared is going to be 16. And that's going to be our equation. Oh, that was real bad. Yeah, just don't mind that. That's going to be our equation for this graph. Here, our center is about 5, -2. 5, -2. And then, so that means we're going to do, and also, is this a vertical or horizontal parabola? It's actually going to be horizontal, so our x term is going to come first. So I'm going to write x minus 5, right? It's always opposite, squared over something, and then minus y plus 2 squared over something equals 1. And so our a value is going to be our distance from our center to our vertex, or to our vertices. That's going to be 3. And so a squared is equal to 3 squared, which is 9. So we're going to put this over 9. And here we're going to have our b values from our center to our co-vertice. That's going to be 7 units. And so our denominator here is equal to b squared, which is equal to 7 squared, which is equal to 49. And that's our equation. And so here, now what we essentially just want to do is we want to get practice with creating equations when we're given certain aspects of our hyperbola. So when we're given our vertices and co-vertices, or our foci, just get some practice with this. So we're just going to jump around with these. Here, one thing to know is that our center is going to be the midpoint of our vertices, or the center is going to be the midpoint of our co-vertices. And so our midpoint formula, I'm just going to write it out one more time. It's just going to be x1 plus x2 over 2, and then y1 plus y2 over 2. So here, for example, if we try to find the midpoint of 5, 0, and -5, 0, we have the same y value, so it's just going to stay 0. And then our x, we're going to have 5 plus -5, which is 0, divided by 2 is 0. In this case, it's pretty apparent that the center is 0, 0. But it might get more complicated in other problems. And here, our vertices are going to be 5 units away from our center. So that means a is equal to 5. Our co-vertices are going to be 2 units away from our center. So that means our b value is going to be equal to 2. And so in other cases where it's not as simple, where it's the center is not just the origin, you can just subtract the 2, use the distance formula if needed, but it is going to be either straight up or straight across, and that way you'll find your a and b values. And so since our center is at 0, 0, and our vertices are plus or minus 5 in the x direction. So that means if, let's just create a graph. If this is our center, our vertices are going to be here and here. That means we're going to be creating graphs that go like that. And that's going to be a horizontal hyperbola. So that means our x value is going to come first. Since we don't have any horizontal shifts, it's just x squared over a squared, so 5 squared, which is 25, minus y squared, since no vertical shifts, over b squared, which is 2 squared, which is 4, and that's all equal to 1. And here you would just use the exact same strategy. Now let's do number 7. So number 7, and by the way, all of these 3, 4, 5, and 6, we're just going to be using the exact same strategy. Find the midpoint, and you can use the vertices or the co-vertices to find the midpoint, which is just going to be the center. And then find the distance from the center of each of those vertices and co-vertices, and from there we find our a and b values. And you have all your components to make an equation from there. In this case, let's do a, where our center is not the origin. So I'm going to find the midpoint between 2, 5 and 6, 5. And so in this case, I see that we have the same y value, so I'm just going to find the midpoint of 2 and 6, which we can just see that it's going to be 4. But if we wanted to do it, we'd say, right, we have x1 plus x2 over 2. So we're just going to say, we would say 2 plus 6 over 2, which is 8 over 2, which is equal to 4. So this is our center. And now we want to find the distance from our center to our vertices. We see that 6 minus 4, or 4 minus 2, is just going to be 2. And since it's our vertices, that's going to be our a value. So a is equal to 2. And we're able to just subtract because we're just going horizontally and vertically. We don't, in this course, we don't graph hyperbolas. It'd be super weird if we tried to graph hyperbolas where it's not either directly horizontal hyperbolas or directly vertical. Anyways, I digress. Now we find the distance from each of our foci to the center. And that's going to be our c value. And so 4 minus 1 is just going to be 3. 7 minus 4 is just going to be 3. Now we use c squared equals a squared plus b squared. And so that's going to give us c squared is 9. A squared is 4. So that means b squared is equal to 5. That means b is equal to root 5. But really, we could just stop at b squared. Anyways, this is our center. And by the way, if we just want to visualize this, you don't need to write this down. Sometimes it helps. But just to visualize, our center would be somewhere like there. And then our vertices would be 2, 5 and 6, 5. And so that means we're going to have a horizontal hyperbola, right? Because they're going the x direction. And so that means we're going to have our x term first. So we do x minus 4 squared over a squared, which is 2. So 2 squared is 4. So over 4 minus y minus 5 squared over our b value, b squared, which is equal to 5. So over 5 equals 1. That's our equation. And here we'll just do one where we have our co-vertices and foci, but it's generally the same process. So we find the midpoint of these two co-vertices. And so I see that we have -3 constant as our y value. So I can already just say our center, or y value for our center, is just going to be -3, because the midpoint between -3 and -3 is just -3. And now I'm going to find the midpoint between 5 and -7. So I'm going to do x1 plus x2 over 2. So we're going to get 5 minus 7, which is -2 over 2, which is equal to -1. So our center is -1, -3. And here now we find the distance from our center to our co-vertex, or co-vertices, which we can just see -1 to 5 is just going to be 6 units, and -1 to -7 is going to be 6 units. And since we're talking about our co-vertices here, that means we're talking about our b value. So b is equal to, what did I say, 6. And at this point, now we also want to find our c value, because we're given our foci. So the distance from -1, or sorry, right, never mind. We have a constant value for our x value between our center and our foci. So now we just need to find the difference between -3 and 7 and -3 and -13. That just is going to be 10. So c equals 10. Now we use c squared equals a squared plus b squared. So c squared is equal to 100. A squared we're trying to find. Then b squared is equal to 36. So that means if we move that 36 over a squared, sorry about that, that's real bad. A squared is equal to 64, which means a is equal to 8. Now here, what I would do if we just visualize this, our center is -1, -3, so something there. Then our co-vertices are going to be 5, -3, so maybe something here, -7, -3, so maybe something there. And then our foci, right, I'm just going to do a different color. Our foci are going to be -1, 7, so all the way up here, maybe. This isn't really drawn to scale. But essentially what this means, our foci are sort of inside the curves of our actual hyperbola. So we're going to have something that looks like this. So that's going to be a vertical hyperbola. And that means our first term is going to be y. So we're going to have y minus -3, which is y plus 3, over our a value. And a is equal to 8. So y plus 3 over a squared, 8 squared, 64, minus x minus -1, which is plus 1, squared, over b squared, which is 6 squared, 36. And that's going to be equal to 1. That's just going to be our equation. We're just going to use the same strategy for number 12. And so ideally from all these different problems, we can get some practice and become a lot more comfortable with graphing hyperbolas and using components and given information about hyperbolas to come up with equations, and also using completing the square to help us find those equations. So ideally, you have a much better understanding, or at least starting to have a much better understanding of hyperbolas after this lecture. If you have any questions, go to Mr. Whitaker, use the internet, use the tutoring center. Certainly come to me. I'm more than happy to help. And yeah, good luck. Thank you.